Elements of statistical decision-making. 1. Degrees of freedom definition. Degrees of freedom are the number of independent values that a statistical analysis can estimate. You can also think of it as the number of values that are free to vary as you estimate parameters. DF encompasses the notion that the amount of independent information you have limits the number of parameters that you can estimate. Typically, the degrees of freedom equals your sample size minus the number of parameters you need to calculate during an analysis. It is usually a positive whole number. X. Suppose we collect the random sample of observations shown below. Now, imagine we know the mean, but we don't know the value of an observation, the X. Values: 6, 8, 5, 9, 6, 8, 4, 11, 7, X. Average equals 6, 9. Sum equals 69. The mean is 6.9, and it is based on 10 values. So, we know that the values must sum to 69 based on the equation for the mean. Using simple algebra, 64 plus x equals 69, we know that x must equal 5. 2. Types of errors, error level. What a researcher does in scientific research is test hypotheses to determine whether to accept or reject them. This process is similar to a courtroom situation, where we assume that the defendant is innocent, the null hypothesis. In this context, 2 types of errors can occur. Convicting an innocent person, type 1 error. Acquitting a guilty person, type 2 error. Since statistics deals with probabilities rather than certainties, there is always a chance that our decisions may be incorrect. When testing, we arrive at a conclusion of rejecting the null hypothesis or failing to reject the null hypothesis. Such conclusions are sometimes correct and sometimes incorrect, even when we have followed all the correct procedures. We use incomplete sample data to reach a conclusion, and there is always the possibility of reaching the wrong conclusion. There are 4 possible conclusions to reach from hypothesis testing. Of the 4 possible outcomes, 2 are correct and 2 are not correct. Type 1 error, proportionality, the probability of rejecting the null hypothesis when it is actually true. Type 2 error, SS, the probability of accepting the null hypothesis when it is actually false. Power of the test, 1 SS, the probability of rejecting the null hypothesis when it is actually false, which is a correct decision. Confidence level, 1, proportionality, the probability of accepting the null hypothesis when it is actually true, which is a correct decision. In general, type 1 errors are considered more serious. One step in the hypothesis test procedure involves selecting the significance level, alpha, which is the probability of rejecting the null hypothesis when it is correct. So the researcher can select the level of significance that minimizes type 1 errors. However, there is a mathematical relationship between alpha, beta, and n, sample size. As alpha increases, beta decreases. As alpha decreases, beta increases. As sample size increases, n, both alpha and beta decrease. 3. Statistical significance and its levels in social sciences. Statistical significance is a measure used in scientific research to determine whether the results obtained occurred by chance or reflect a real pattern in the data. Statistical significance tests are used to evaluate hypotheses. If a result is statistically significant, it means that it is not merely a random coincidence but rather indicates a strong likelihood of a certain relationship or effect. Levels of statistical significance. Statistical significance depends on the significance level, alpha, which is predetermined by the researcher. This level determines whether to accept or reject the null hypothesis, H. The most commonly used significance levels in social sciences are significance level 0.05, 5%. This is the most widely used level, meaning there is a 5% probability that the results occurred by chance and a 95% probability that they are real. Significance level 0.01, 1%. This is a more stringent level, used when it is crucial to minimize the probability of a type 1 error, rejecting the null hypothesis when it is actually true. Importance of statistical significance in social sciences. Helps in testing scientific hypotheses. Enables researchers to verify relationships between variables. Reduces the chances of obtaining random results. Supports decision-making based on scientific evidence.